Hello everyone! Have you ever built a train station in Satisfactory and you're having a hard time making it transfer resources properly? Well, it's probably because of the animation. When the train loads and unloads, the resources can no longer be transferred between the station and the outside world. You can see right there were water bottles being transferred and they are no longer transferred. My belts are empty, and at the same time I cannot access the train or the train station itself. It is locked out during that animation. Now, this is actually a case of game balance. It had to be done because trains don't consume any resources, like cars consume fuel, drones consume batteries. That's why their stations are simple. Trains only consume electricity, that makes them very easy to manage. So for that reason, that's why it gets locked out like that. But then, what about the numbers? How much can you actually transfer per minute, considering, that locking moment? Specifically, if you have more trains per minute, you're gonna have more resources transferred to between the train and the station. But then the resources, more train per minute also means more locking times, which means less resources being transferred in and out of the station and the rest of your factory. So in that case, what are the numbers? How do you get optimal numbers? Well, luckily for you, I've done the math. If you just care about the numbers, this is what you need. Depending on the size of the stack, your train interval should be bigger or smaller for perfect maximum optimization. If you're not transferring a lot of resources per minute, then that doesn't matter. This video is actually about making it as optimal as possible, and if you're pushing it to the extreme, like I basically did quite a lot actually. Um, so if all you wanted are the numbers, here are the numbers. If you want to know how I got to the numbers, then stick around. I'm gonna do the explanation. So first off, I just want to say that I invented this term, the metric minute. That's just converting minute into the metric system. So you just divide by 60. It gives you a number that's metric minute. It makes mathematics very much easier this way rather than actually, you know, transferring your minutes into seconds and then blah 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 blah. So metric minute, you just divide into 60. It's way easier. So you have 32 stacks per car. And considering stacks of 100, this is what I'm transferring myself. Then you have a very simple math to know the max amount of resources you can transfer per train. Which means essentially if you have more trains per minute, you're gonna have more cars. So this is your interval between each train. So if you have a train every 2.5 minutes, that would be 2.5 in this particular case. And so you just do that very easy math of 3200 divided by that number equals the max amount that you could transfer. Essentially, it's between the trains and the station. But then where it usually really matters is between the station and the outside world, which is the maximum amount that can be transferred in your belts. So essentially, this is a quadratic equation because the more, like, it's exponential kind of thing. The more trains per minute, the less you can get transferred per minute. Uh, so I'm not gonna go into detail on how I got exactly that equation. I'm just gonna tell you real quick this very simple fact. 1560 is the maximum number of belt if you have two belt tier 5s, which is 780 per minute each. And 728 is the number of time, it's that number times the amount that it is being looked out. So when you do that transfer, like I said, it's looking out the station. It's looking it out actually for 27 seconds, but I've used 28 for the mat just to make sure that there wouldn't be any mistake in case I didn't time it right, or there's lag involved sometimes, things like that. So for the sake of safety, I've used 28 seconds for the for each time that it's locked out. So the reality is that you could actually transfer a little bit more than this per minute, but using these numbers, you will be safe. You don't need to optimize more than that anyway. Like, it's not about making it exact, it's about making it enough that you will be able to transfer everything. Um, so, how do you solve these two equations together to make sure to get, that optimal point? So, like I mentioned earlier, if we go back to the graph, um, the more you have trains per minute, you can transfer more and more resources per minute between the train and the station, but then comes a point where the station can no longer release or get in those resources through the outside belt because it keeps getting locked out with the transfer animations. So you don't want to have not enough trains. You also don't want to have too much trains. You want to get as close as possible to this. How do you resolve that? Math. It's math time. So this is how I got this equation. Essentially, the peak would be when this is equal to this. Then you transfer this to the other side, equals 0. That's, advanced algebra, which I had a good time to do, actually. It's really fun. I miss doing math like that. Um, so essentially, if you know your math, this here means that this can be equal to 0 or this can be equal to 0. So you pick one or the other. I picked this one, which resolved into this. So this here is the optimal number. This is your interval between each train in metric minute, the term that I invented, uh, if you have stacks of 100, which is this one right here. I've already done the math with the other ones. The only thing that changes in all this is this number. Because since you have like smaller or bigger stacks, then you have less or more that fits in one freight car. Essentially, that's why it is. Now, if you stick to those numbers, you will be fine. But you might not be transferring exactly 1400 per minute, you might be transferring less than that. So you might not need exactly a train every 2 minutes and 15, you might have a little bit more leeway with your interval between each train. So how do you know what is good enough? Well, this is where this comes in. Let's say that I wanted to transfer 1200 per minute. Like this. There we go. Then what you want to do here is this is your amount of per minute that you are trying to transfer. This is per car, of course. You can have more cars, and each car would transfer this amount. So let's bring in the calculator. So in this particular case, we're trying to transfer 1200 per minute. So replace the y by 1200 and resolve the equation. It's going to give you the interval in between each train in metric minutes. So you just multiply by 60 to get the time in actual seconds. So, oh, and this is for stacks of 100. All right, if you have different stacks, if you have stacks of 50, you divide that into 2. Stacks of 200, you multiply it by 2. Stacks of 500 is multiplied by 5. This number does not change. This part doesn't change because this is only related to the belts. This is the stacks. So in this particular case, let's say that it's stacks of 100. So 32 divided by 12, 2.6. So that's 2.6. And you multiply that by 60, and that gives you 160 or 2 minutes and 40. 2 minute 40 in between each train. Between each train. So that's your maximum amount. And now for the minimum, you want to resolve it in order. So first you do this. 60 minus 1200. 360. So then you do this part. 728 divided by 360. That gives you this number. And this is just the root, the square root of it. And there's actually the button on the calculator. It's if you have the calculator on your computer, it essentially the button looks like this. Okay, this is what you need to find the square root. You just press once on this, and there you go. You got it. It's 1.42. 0.42. Or once again times 60, 85 seconds. So 1 minute and 25 seconds. So in the case of transferring 1200 per minute in stacks of 100, you could have a train once every 2 minute 40, once every 1 minute 25, or anything in between those two numbers, and you would be able to transfer enough resources that you would be able to feed your machines, and you won't have anything accumulating on the trains. The transfer is going to be correct. So that's how you can find your possible range, like minimum, maximum numbers. Now, let's talk about how do you build your rail system to have this perfectly optimized. So let's bring back paint here and clear that out. There we go. So let's say that I have a circuit here. This is what my rail system looks like. Then you have here, you have a station. Well, yeah, why not? There we go. You have one station here, have another station here, another station here, and that kind of looks like a foot. Let's call it the foot rail. So you have these stations here, and usually what's gonna happen is you're gonna have one big station where you're transferring a lot of resources. And let's say it goes this way. But then the other, like in this case, let's say this is the big station. And then you have other station here. This is unloading, and it's unloading a lot of stuff. And then this is loading a little bit, loading a little bit. So essentially, you want to have this one being perfectly optimized. Those doesn't really matter as much. If anything, you can optimize the whole thing so that it is perfect. What you want to do is you have your block sections, right? So you have block sections like this. It's gonna so it's your stop signs. So if we go back to the game real quick, you can see here the block signals. They create block sections, and you can see the block sections being different colors on the rail itself. And so if you don't know, a block signal will prevent a train from moving forward if, like, the train will stop here if there's another train waiting there. And the train will wait until this section here is cleared, and then it can move forward. So back to the beautiful quality drawing. Essentially, having block sections like that will separate into multiple, into multiple colors. You can see it as you're building. And what you want to do is, because you always want to have enough trains, right? But you never want to have too much. So if you have one big section like here, have one very big section, this is gonna set the interval between your trains. So essentially, you're gonna have one train. You always want to have one train waiting here while there's another that is going on that section. And as this one leaves this section, then this one is going to go in, and you want to have another train that comes and wait here before this one has exited this section. That way you always have trains going through this station at maximum, not necessarily maximum interval, but the same interval. This is how you make it exactly the same interval all the time. And if you move this section, this block signal a little bit further or a little bit closer, that change will affect the interval in between the train, of course. But that change will that interval will always be the same everywhere. Like even this station here will have the trains go in at the same interval, and it's gonna be the same interval as this one. But do keep in mind that if you do make adjustments like this as you're building your system, it's gonna be instantly felt in this section, in this station, and it almost instantly felt in the next one, but it's gonna take a while for it to go through all the stations. So just keep in mind, like especially this one, this is going to be the last one to be affected by this new interval that you just made the difference here. So just keep in mind when you time your interval between each train that if you make a change, it can take a moment to be felt throughout the rest of the system. So find a station where it's easy to have that interval change as soon as possible and then time it there. Now this is for a single loop system that has no intersection with other systems. Which is essentially what I did. If I show you the map here real quick, you can see this one rail is not connected to anything else. But if I show you the full map, you can see that there is train station all around the world. So they're all single rail systems. There's no intersection. And that simply made it easier for managing the interval between each train. But that might not be your case. Most people like to make all their train system integrated, right? So in this particular case, then you would have, let's say that this is your system, and then you have a branch out here into another system, and a branch out here. Again, you know, let's say you have intersections like this. This interval here will guarantee you timing in between your train and your first intersection. The only thing is, as soon as you have an intersection like this, then you have a risk of another train coming in and essentially disturbing your timing on this one rail. So if that's the case, then just make sure that you set your timing here. You want to have one long block section which sets the timing for all your trains, and you want to have one before where your station matters. Whatever station needs to load or unload a lot of resources, this is where you want to set your interval to be precise. Now, if you have multiple stations that needs also precise intervals, then let's say you only have, let's say you have this, and you want to set another, let's say this one and this one needs to have precise intervals, right? Then you can just essentially do the same thing where you're gonna have this being one block section as well. So that's gonna set your interval here, and it's also gonna set it here. And then you just gotta make sure that both intervals are good enough to carry the right amount of resources per minute. So it's still something that can be worked around. And in my particular case, it's actually the case for this rail that I just showed you, because I have here, it's the water packaging station, and in my tower itself I have the water unpackaging system. And so I essentially bring in full containers of water and returning empty containers, empty canisters. And so both of these stations need to have a very precise interval. So because of that, I have one very, very long block section here. You can see the train is waiting here, and that sets my interval. And then you have another one here that is very long as well, but it just happens that there's not a train waiting for it. Well, actually, it's right here. It starts right here. So yeah, that way I have my system work in two stations. I essentially did that beautiful drawing, isn't it beautiful? So as long as you do this, then you should be fine. One last note. Um, if you're starting to build a lot and your game slows down, do keep in mind that train speed is actually affected by performance. If you have a lot of lag, it's gonna mess up your timing. So if that's the case, well, maybe build less, or you can also adjust the interval on your train. Reduce the size of your block sections as needed, but that also makes it that if you ever want to share your map with someone that has a better computer than yours, it's gonna mess up the interval. Alright, just keep that in mind. So, yeah, that's essentially everything. I hope this was useful, and I hope this beautiful drawing haunts your dreams. Until next time, have a moo, everyone.